Hey guys, Mr. Backwork here. In this video, we're going to look at products of special polynomials. Now, as we're looking at these special products, I do want to remind you that we can still FOIL these problems out, and we can still use the box method if we want to. I'm just going to be showing you some different shortcuts that we can use if we do have one of these special products happening. So the first special product that we're going to look at is having a binomial being squared with addition in there. So here we have x plus 3 and we're squaring that. So I mentioned that we could still FOIL this. So here's what that would look like. Remember, squaring something means that we're multiplying it by itself. So having x plus 3 squared really means we're taking x plus 3 and multiplying by another x plus 3. And then from there, we can use our FOIL, or we could use the box method too. For the f in FOIL, we're going to multiply those first terms together. So x times x is x squared. O, we're going to multiply the outside things together. So x times 3 is 3x. I, we're going to multiply the inside things together. 3 times x is 3x. And L, we're going to multiply the last things together. 3 times 3 is 9. Now we do have some like terms in the middle that we're going to be able to add together. 3x plus 3 more x is 6x. So we get x squared plus 6x plus 9. So FOILing still works, but we're going to focus on some of the shortcuts that we can use with these special polynomials. So the way this is going to work, if we have some general binomial being squared with addition on the inside, the shortcut that we can take, if we have a plus b, we're going to go a squared plus 2 times a times b, and then we're going to add b squared onto the end. And then we would make any simplifications that we need to. So in this case, the x is the a value, and the 3 is the b value. So according to my shortcut, I'm supposed to take the a value and square it. So in this case, we've got the x, and we're going to square that, plus, and I'm supposed to do 2 times the a value times the b value. So 2 times the a value times the b value, and then I'm supposed to take the b value and square it. So 3 squared. Now we are going to simplify this down. X squared doesn't really simplify down. When you take x and square it, you just get x squared. Now in the middle here, where we're taking 2 times x times 3, if I take 2 times the 3, that's going to be 6, but we still have that x attached on there. And then on the end, if we take 3 and square it, we get 9. So if we were to go through and actually FOIL all this one out, or use our box method, the answer we would get is x squared plus 6x plus 9. But again, this is just a shortcut that we can use so that we don't have to take all those steps for FOILing or for drawing out our boxes and doing that box method. Now this next one is similar, but notice there's subtraction happening. So we have x minus 2 being squared, but there's a similar pattern that we can use. If we have some general binomial with subtraction being squared, we're still going to go a squared, but this time we're going to do minus 2 times a times b, and then we're still going to do plus b squared. So in this case, the x is still the a value, and here we've got 2 as this b value on the end. So I'm supposed to go with a squared, so x squared minus 2 times the a value times the b value, so times the x and times the 2, and then plus the 2 squared plus the b value squared. Well, when we take x and square it, we're just going to get x squared. In the middle, if I take this negative 2 times this 2, I'm going to get negative 4, but we still have that x attached to it. And then if I take this 2 and square it, I'm going to get plus 4. So I get x squared minus 4x plus 4. Now in this example, we've got 4x minus y being squared, so it's going to be a lot like that subtraction one that we just looked at. So we've got a minus b, and we're squaring it, so we're going to do a squared minus 2ab plus b squared. So in this case, the 4x is the a value, and the y is the b value. So first, I'm supposed to take a and square it, so 4x and square that, minus 2 times the a value, so 4x times the b value, which is y, and then plus the b value, so y squared. Now when I take 4x and square it, well, 4 squared is 16, and if I square the x, then I'm just going to get x squared minus, now 2 times 4 is 8x, and I can't really multiply the x and the y together, so I'm just going to write it as minus 8xy. And then on the back end, when I take that y and square it, it's just going to stay as y squared. So I get 16x squared minus 8xy plus y squared. Now for this last one, we've got addition happening, so 3m plus n being squared. So we're going to use that addition pattern that we looked at the very beginning. So we're going to do a squared plus 2ab plus b squared. So in this case, the 3m is my a value, and the n is my b value. So when I take a and square it, I have to go 3m and square all of that, plus 2 times the a value, so 3m times the b value, which is n, and then plus the b value, so n squared. When I take 3m and square it, 3 squared is 9, and m squared is just m squared. In the middle, 2 times 3 is 6. I can't really multiply m and n together, so I'm just going to leave it as mn. And then on the back end, when we take this n and square it, we just get n squared. So we get 9m squared plus 6mn plus n squared as our final answer on this one. Now the other kind of special product that we're going to take a look at is a sum and a difference. So here we have x plus 7 times x minus 7. So these are almost exactly the same binomial. The only difference is that one of them has addition in the middle and the other one has subtraction in the middle. If you have a sum and a difference pattern, so for example, a plus b times a minus b, the general result is that we're going to have a squared minus b squared as our final answer. So as we're taking a look at this one, these x's represent the a value, and the 7s represent the b value. Again, the only difference in these two binomials is that this first one has addition between it and the second one has subtraction. The first terms are still the same and the last terms are still exactly the same. It's just plus and minus. It's that sum and difference pattern. So if we take the a value and square it minus the b value and square it, we get x squared minus 7 squared. Well, when we take x and square it, we're just going to get x squared minus, when I take 7 and square it, I get 49. So my final answer would be x squared minus 49. As we take a look at this one, we've got t plus 5 being multiplied by t minus 5. So just like we saw, the answer we get should just be a squared minus b squared. So in this case, the t's represent the a value, and the 5s represent the b value. So I need to take a and square it, so t squared minus that b value squared, so 5 squared. Well, when I take t and square it, I just get t squared, minus, when I take 5 and square it, I get 25. So I get t squared minus 25 as my final answer. As we take a look at this one, we've got 3x minus y and 3x plus y. Now, it doesn't matter that the subtraction is coming first and the addition is coming second. We're still going to have the exact same pattern that we've been working with. We're still going to do a squared minus b squared. So in this case, the 3x represents the a value, and the y represents the b value. So when I do a squared, I have to do 3x and square that, minus the b value squared, so y squared. Now when I take 3x and square it, 3 squared is 9, and x squared is just x squared. Minus, when I take y and square it, I just get y squared. So my final answer on this one is 9x squared minus y squared. And then our last example here, we've got 2x minus 1 and 2x plus 1. Again, we're going to have that a squared minus b squared final answer. So here the 2x is representing the a value, and the 1 is representing the b value. So when I take a and square it, I need to do 2x squared minus the b value squared, so 1 squared. 2x squared, well, 2 squared is 4, and x squared is just x squared, minus, when I take 1 and square it, I just get 1. So my final answer on this one is 4x squared minus 1. That's going to be it for this video. Thanks for watching.